Alright, today we are looking at finding the perimeters and areas of complex shapes. And these are pretty involved sometimes, but just take your time. Sometimes you need to start with finding missing dimensions, and there's some basic formulas you do need to commit to memory as well. So on number 1, we see that we have 10 by 10, so we can fill out this height of the triangle as 10 also. And this 15 is referring to this entire length, so that means this has to also be 10. And we can fill in this remainder, length has to be 5. Okay, so what else can we find? We can find the hypotenuse of this right triangle by using the Pythagorean theorem. So 10 squared plus 5 squared equals c squared. And after plugging this into your calculator and solving, you should get C is about 11.2. Remember, the more work you show here, the easier it is to grade, so I always like to try to label everything in my picture as well as showing work. So the perimeter we can easily find here. We're just going to add up the outside dimensions. So we have 15 plus 10 plus 10 plus 11.2. And again, I always remind my students to write this out in case if they plug it into their calculator wrong, I can still give you most credit. So after putting this into your calculator, you should get 46.2 meters. Okay, so for the area, two different ways you could do it. You could add the area of the square and the area of the triangle together, or you could use your trapezoid formula. If you do the square, this portion here is going to be 10 by 10, which is 100. The area of the triangle, remember the area of a triangle formula is base times height divided by 2. So we're going to be taking 10 times 5 divided by 2, which is going to give you an area of 25 for that triangle. So the area can be found as adding the area of the square and the triangle. 100 plus 25, we get an area of 125. Remember, for meters squared, it's your square units for area. Okay, so that's number 1. Number 2, we have a semicircle and another triangle. Notice these tick marks mean that these are equivalent, so if this length is 20, we can fill in 20 as well here. And notice again, this should be labeled, but it's a right triangle. 20 squared plus 20 squared should be equal to the hypotenuse squared using the Pythagorean theorem again. And when you solve for C, you should get 28.3 for that length. Now for the semicircle, remember the formula for the circumference of a circle is diameter times pi. The diameter is 20, so if I were to have a full circle all the way around is going to be 20 pi. But I'm not going all the way around, just halfway around, so don't forget to divide that by 2. So the circumference of a semicircle is going to be 10 pi on this problem, which is 31.4. So we have enough information to find the perimeter. We have 28.3 plus 31.4 plus 20. Adding these all up, we get 79.7 centimeters. So for the area, we need to find the area of the triangle, which is going to be 20 times 20 divided by 2. So remember, base times height divided by 2. 400 divided by 2 would give me 200 for that triangle. And the area of the semicircle, remember a full circle is pi times radius squared. Well, notice the diameter is 20, so the radius is going to be half that, or 10. So we get 10 squared times pi. That would be the full circle's area. Remember, we have to divide that by 2 to get half. So 100 pi divided by 2, 50 pi. And if you compute the decimal equivalent, that should be 157.1. Okay. So by adding these two areas together, we will get the full area of 357.1 squared centimeters. Okay. So again, really involved problems. Take your time, find all those missing dimensions, and remember your basic formulas. So there are 4 problems for you to try here. I'll try to put these all here so you can see them. And pause the video and I'll put the solutions up so you can check your work. All right, here are the solutions to 3 and 4. So this one was a little tricky one. Noticing that we had 10 and 10, we have an isosceles trapezoid if you were to complete the entire figure. So if this entire length is 25 and this is 13, you could figure out this was 6 and 6. And notice I drew in the heights of the triangles. And so if we're looking at this triangle, notice I can solve for the height because I know 6 and 10. So again, we're using the Pythagorean theorem, but this time solving for not the hypotenuse, we get 8. So if this entire length is 8, we can solve for this length, which is 5. So different ways to do this problem, but you could find the area of this triangle, the area of this rectangle, and the area of this triangle once you find all those dimensions. Just using your basic formulas, add these 3 areas together to get 113. And remember, the perimeter is just found by adding up all those lengths on the outside. So check those numbers. If you got that wrong, see where you made a mistake. Okay, and number 4, check your solutions here. You should get 100.5 for the area of the semicircle, 192 for the area of the rectangle, and 64 for the area of the triangle. You could have done a trapezoid as well, but if you add these 3 together, you should still get the same area depending on, or regardless of which way you found your answer. And then the circumference, remember, halfway around is going to be diameter pi divided by 2. So 8 pi or 25.1 halfway around. So the circumference is 12 plus 25.1 plus 20 plus, you had to find this distance by, again, using Pythagorean theorem, 17.9. So you get a perimeter of 75 inches. Okay, and the answers to the last 2. Go ahead and look those over, and hopefully this helped you out.